So this is a walkthrough of one of the programming questions that appears on paper 3. So paper 3 isn't an on-screen exam, but it is a exam that has programming elements in it. And this question is about linked lists. Now, you may have come across linked lists before, but here's a little bit of revision. I always recommend going to Ada Computer Science for some detailed walkthroughs, but I stole the picture which shows you what a linked list is. And as you can see, it is a list of elements, in this case bat, frog, lion and seal, which is actually in alphabetical order. And you can see that the item bat here is the piece of data, and it is stored at index 1290, and it indicates what the next item is in the linked list by having a next property which stores the address of the next element. So we then go to 812 and the data says frog, and then it has a next element which is stored at 208, which we can see is the one called lion, and its next element is 645, which is seal. And you can see that's the end of the list because there isn't nothing in its next element. Okay, so that's how a linked list works. It's quite an efficient data structure that gets stored because, for example, if we wanted to delete frog out of the list, unlike a traditional array, if we removed an item, we'd either have a big gap there or we'd have to shuffle everything up to remove the gap. For this, all we would need to do is change the next pointer from 812 and just change it to 208. We basically take the item from there and the next value from there and stick it in the next value for there. So you can see that deleting and adding items is actually a big O of 1, so a constant type complexity. Anyway, that's not what they're asking in the question. Now, on the Ada Computer Science platform, it goes into lots of lovely details about how you might implement that linked list in reality, from either creating a record that has two pieces of data, so the data and the next, or making it a class, an object-oriented approach. But what you often see in exam questions is the idea that you have an array-based linked list. And it's unusual, but it does appear on past exam papers, and that's what this exam question is about. But just to show you how it might be stored, you're effectively having, it's technically, I guess it's a 2D array, but you would have the data being stored in one column. So there's, I don't know why they've not stuck with the bat and the lion and the frog, but we've got names here. And then we've got the next position, which is being stored there. So you can see in this case, head, because this is a separate variable, head is set to 2. So in this case, Sasha is the starting item, followed by 0, which is Greta. So that Greta would be the next item, followed by 1, which would be George, followed by 4, which would be Martin, followed by Faisal, and in this case we've got null, which proves that Faisal is the last one on the list. So in this case it is in alphabetical order, but that's the order of items in this linked list. Okay, so things to remember is you get a big array of data for your linked list and you have a variable called head. Now let's look at the question. So on this slide is a screenshot of the question from, I can't remember which year, but this is from CIE paper 3. So have a quick read of the question. We're talking about flowers and we're using this linked list to store them in alphabetical order. So we've got two 1D arrays. So this is one array flower and this one is next pointer, which is another 1D array. We've got a head pointer variable, which is set to 6, and we can tell when the end happens, the pointer is equal to 0. So we're given this starting table, well, it is a table effectively, showing the two arrays, flower and next pointer. So if you look, we can see what is the first item of the list. If you said it was Dahlia, you are correct because head pointer is 6 and Dahlia is there. So this is the first item in the list, followed by number 5, which is Daisy, followed by number 3, which is Foxglove, followed by number 10, which is Hydrangea. I'm not going to go through all of those, but effectively it puts them into alphabetical order. And we can see that the last item is Saxifrage here because it has got a 0. Okay. So then it goes on. So you'll usually get a scenario like this in a question. If I go to the next page, it says several flower names have been deleted from a linked list. So as I said earlier, all you need to do when you delete items from a linked list is simply change the next pointer. So it'll be these items in the next pointer that get changed around. Also, the head pointer is going to get changed because, notice Dahlia, which was our original start, has now been deleted. So have a little bit of a think. I'll let you pause and try and work out what should be next. And for these sort of questions, you can do working out on the table. In fact, that's what I'm going to do here. If it helps you, make sure you get it right. I think the examiner would much rather you did your working out there because you might get some credit, even if you didn't get the final answer completely right. It's 3 marks, so, a decent amount of marks for something that is essentially quite straightforward. Okay, let's investigate the answer. Well, as Dahlia now no longer exists, the head pointer was 6, but the next one in the list, as we saw, was actually Daisy. That comes after Dahlia, so that will be 5. So this starts, and then Daisy points to, it did point to, let's go back here, it did point to number 3, so let's write that in there. And 3 is still there, so Foxglove is okay, so we don't need to change that. So let's have a look at what Foxglove pointed to. It was 10. But, oh no, Hydrangea has been removed. So what was here in Hydrangea, in this bit, let's go back. Hydrangea was 4, so we now put 4 into there. So let's have a look at what's at number 4. That's at Iris. So we need to find out what was the next pointer for Iris. That was number 9. So let's just write that in there. And Lily is still there, so that's fine. We don't need to do anything about changing this next pointer. So let's have a look at what Lily was. That was number 8. Let's write that there. And Lupin is still there, so we write down what was in Lupin's. That was number 2. And, oh no, Marigold has disappeared, so we can't go to Lupin. We have to go to we can't go to Marigold. So let's see, Marigold was pointing to 1, so that now appears down here. So if we go 1, that goes to Rose. Rose is still all right, so let's have a look at what Rose pointed to. Rose pointed to 7. 7 has been deleted. So if we now go back and see so that was 0 because that was the last one on the list. So we change that one to 0. So I think leaving those crossed out helps the examiner to know that you knew what you were talking about. But the final answer should be 0, 4, 9, 3, 1 and 8. So if I scooch ahead and look at the answer 0, 4, 9, 3, 1 and 8. So then we've got, after that question, we have got the pseudocode algorithm. So as you may have seen before, the pseudocode is written in its own version of pseudocode, not Python, not C#. It remains to be seen how strict they are about the actual marks that you get given, but I would recommend that you have a look at some examples of their pseudocode so you're not completely thrown when you see it. So this is an algorithm, takes in the input of a flower name, searches the linked list in order for the flower name. If it's found, a message is output. If it's not found, another message is output. So we've got a big fat if that needs to be written here. And then it terminates when the next pointer value is equal to 0. So we've got 5 bullet points and 5 spaces here. Have a think about what needs to be written. My tip is to look at the program as a whole. So look at everything that's in there, because they've already created variables that you're going to use, like found and pointer and flower. Okay, so remember that the two arrays we've got are flower and next pointer. Okay, so either press pause and have a think, or try and guess what we're going to write first of all. And again, this is a 5-mark question, so have a go. You could get 1 or 2 marks even if you're not really sure. Okay, let's have a look at the answers. So this is their way of prompting for an input. So in their pseudocode, you would write input and then just flower name. It has to be flower name because notice it's being used down here. So you can't just make up your own variable, sorry. And then we've got something that looks like it's going to be a construct, because can you see that the lines inside it are indented? So it's going to be an if or a while or a for loop or something like that. So we want to keep repeating this until we get to the end, don't we? So it can't be a for, because a for loop runs for a certain amount of time. It has to be a while loop. And the condition we're going to be checking is until the next pointer value is equal to 0. So we could write this in a variety of ways, but we could say while pointer is not equal to 0. Okay, because pointer gets set, you're going to be setting pointer in on this line here. So inside this if block, we've got if the flower pointer is equal to flower name, we know we found it. So we're setting a variable called found, which was initialized to 0, to, this is a good point, we're setting a found equal to 0 up here, but then we're setting found equal to a pointer there. And then we're also setting pointer equal to 0, which is quite cunning because it will then throw us out of the loop. So that's quite nice. But what do we do if it's not equal to flower name? Well, we want to carry on. So we want to go to the next pointer. So in this case, we're going to set pointer equal to next pointer. Next pointer, because that's the name of the array, and then put pointer in square brackets. Because remember, pointer is the actual address of the value of the next pointer. So that should work. And then when we get down to this part here, we're outside of the while. Yeah, there we go. There's another hint that we needed to do a while, because here we go, we've got end while there. So then we've got a missing value there. Well, again, we can look down here for a hint, end if. So clearly this has got to be an if. So what are we testing? Well, this little variable here, found, is being set. So we can say it starts off being 0. So we can say if found is not equal to 0. And then we've got output flower found is found. So that should print out Daisy is found. Otherwise, we can just write in this final space output no flower found or something like that. I don't think it's very specific about what you're supposed to write. Okay, so for 5 marks, I don't think that's too tricky. Should we just have a quick look at the mark scheme? Okay, so we've got input flower name, we've got while pointer is not equal to 0. You can write it as exclamation mark equals if you want rather than that. Then we said pointer is equal to next pointer, we got that one. If pointer is equal to 0, oh, they've got the word then. I don't know whether you'd get into trouble if you didn't put then there. Pointer is equal to 0 then, or you could do found. I can't remember which one we did. I think we did found in the end. And then output the flower you wanted is not in the list. Okay, so a nice little kind of programming but not really programming question that we can practice. Stay tuned. Hopefully next time I do a little mini one of these, we can start talking about translation software. But I will leave it for there for now and see you next time.